Why does metal expand when heated? Have you ever noticed that railway tracks have small gaps between the sections? Or that a stubborn metal lid on a jar becomes way easier to open after running it under hot water? This isn't just a random trick. It's a fascinating principle of physics at play. Let's dive deep into what's actually happening inside that seemingly solid piece of metal. At first glance, metal looks completely solid and still, right? But if we could zoom in, way down to the atomic level, we'd see that it's made of countless tiny particles, or atoms, that are never truly at rest. They are constantly vibrating and jiggling in their fixed positions. Think of it like a massive crowd of people, all standing in place but constantly shifting their weight and moving around a little bit. Now, what happens when we introduce heat? When metal is heated, it absorbs thermal energy. This new energy gets transferred directly to those tiny particles, making them vibrate much faster and more intensely. It's like turning up the music at a party. People start dancing with more energy and take up more space. The same thing happens with the metal's atoms. As they vibrate more vigorously, they start bumping into their neighbors more often and with greater force. To accommodate this increased movement, they need more room. So they push each other slightly further apart. This isn't a huge separation between each individual particle, just a tiny increase in the average distance between them. However, when you add up this small expansion across trillions and trillions of particles that make up the whole piece of metal, the overall effect becomes noticeable. The entire object gets slightly larger in all directions. This phenomenon is called thermal expansion. Engineers and designers have to be very clever about this property. Take bridges, for example. Large metal bridges often have special joints called expansion joints. These look like metal teeth or gaps in the roadway. They are there specifically to give the bridge's metal structure room to expand on hot summer days and contract during cold winter nights. Without these joints, the immense forces created by thermal expansion could cause the metal to buckle, bend, or even crack, which would be incredibly dangerous. The same goes for railway tracks. Those small gaps you see between sections of rail are there for the exact same reason. On a scorching day, the rails expand and fill those gaps. Without them, the tracks would warp and could derail a train. This principle is also incredibly useful in our everyday lives. That tight metal lid on a glass jar? The metal lid and the glass jar both expand when heated, but metals generally expand more than glass for the same temperature change. So, when you run hot water over the lid, it expands just a little bit more than the glass jar it's screwed onto. This slight expansion loosens the grip of the threads, making it much easier to twist off. It's a simple yet brilliant application of physics. And what happens when the metal cools down? The process simply reverses. The particles lose their extra energy, their vibrations slow down, and they settle back closer to each other. The metal shrinks or contracts, returning to its original size. This cycle of expansion and contraction is a fundamental and predictable behavior of most materials, especially metals. So the next time you see a gap in a bridge or a railway track, or you use hot water to open a stubborn jar, you'll know exactly what's happening. It is not magic. It's just the quiet, powerful work of science happening all around us, making our world safer and our lives a little easier. If you found this explanation interesting, let me know your thoughts in the comments below. And tell me, what other everyday science mystery would you like me to unravel next? Thanks for watching, and don't forget to like and subscribe for more deep dives into the world around us.